Hello, this is Jared from Commit to Quality. In today's video, we're going to go over classes in C#. A class is basically a blueprint of an object. It defines data and methods inside it, and it's basically the foundation of object-oriented programming. Now, what I'm going to do in this video, I'm going to create a class which is going to handle kind of player rankings for the simple bug-catching game we're going to make. So before we jump in here, I want to say, if you're working on an enterprise solution, you're not going to always work inside just one file or one like this program file. You're going to have multiple classes, and it's extremely important you understand this as well. So let's jump into it, and let's say right click on our project, add new item. We've already got class selected here, and I'm going to name this player rankings.cs. And you can already see that we've got some scaffolding created for us. We've got these using statements. We have our namespace, which is the name of our project. And then we've got our class inside here. And this internal is something we haven't discussed before. We're going to touch on it in a little second, but it's basically an access modifier that can be applied to classes, methods, properties. And it basically means that everything inside the class is accessible only within our same assembly. So basically inside our same project. Because there's some cases where you can have multiple projects. You do have another one, which is called public, which is less restrictive than internal, and public will allow us to access the class from anywhere and the objects within it. So, like I said, a class is just a blueprint. So what we can do inside here, we can say public string, let's say gamer tag. So we say we're going to make a bug catching game. So we've set this public accessor here, and we set what we want our property to be of gamer tag, which is going to be a type of string. I'm then going to say public int last score, so we can keep track of the score. And I want another one which is going to be public in-game hours, because this is going to be output all as part of our player rankings. We could have probably named this like leaderboard or something to be a little bit easier. And of course, I forgot the type, which is going to be integer. Now, before we move on, I said there's a few others. So we've touched on public and internal and what they are, but we've also got private, which means that this property now is only accessible within my class. It means that if we have properties or methods we don't want anyone to use outside of this class, we can encapsulate them inside here using private. And we also have another one which is protected, which means it's available within inside the class and anything that inherits and its inheritors as well. So anything that inherits player rankings. But for this demo, I'm going to make everything as visible as possible, and I'm going to say public here. So we have our properties inside the class here, but now I want to add some methods. So I'm just going to add a comment saying methods. Public, we're not going to return anything. We're just going to do a console output. So I can say void because we don't want to return anything. Let's say game time, and I'm going to say in game hours plus equals 1. So you might remember from our previous video, all this is going to do is add number 1 to our in-game hours variable. So we're saying we're basically adding 1 hour every time this method is being called. And I'm just going to do a console.writeLine here, which is going to be, let's say, string interpolation, and we'll say gamer tag has logged another hour. Game time is now in-game hours. Don't know why it's added seconds on there, because we don't want seconds. So game time is now in-game hours. So every time this is called, we should have a console output which says it's increased by an hour. We also have the last score property, which we haven't used yet. So let's create another method, and we'll name it public. Now we want to return, is it better than the last score? So we want to make it really simple. So we'll say a boolean of true or false, because that's what we're going to return. And we'll say better than last score. And of course, we want to pass in score because we need to check the current score against the last score. And here then, I'm going to say console.writeLine. We'll use string interpolation again. And we go into, say, gamer tag, which is the name of the person, scored, pass in score. And then we'll add this and say your last score was and whatever last score is here. So all we're doing is doing an output there. We're going to say, because you played, let's increase your game time as well. So here we should see an output of console.writeLine of this, and then we call on this game time method, which is going to add an hour onto it and output this console.writeLine. And now we want to actually do something to say return true or false. So I'll say, let's add a conditional of if score is greater than last score. We'll say last score is now equal to score, and we'll say return true. Because of course, once we've said, yeah, it's all good, we want to make sure our last score is set to our current score for the next time we play in our game. And because we're inside a conditional, we also need to say else, and we'll say last score equals score again, and in here we'll say return false. In this case, we haven't beat our last score, but now we're going to set our last score to equal to whatever the current one was. If this was like a leaderboard ranking, which is probably why I didn't name this leaderboard, this line wouldn't be warranted because we just want to set whatever the highest score in this case is just going to compare us against the last time we played. Awesome. So we've got now our properties inside here. We have our methods of game time and to check if we have better than last score. So let's now go to our program file and let's create an instance of our class. So I'm going to say using commit quality series, just say we're using their namespace. And now we want to create an instance of our class. So we can say player rankings, and let's name this player 1, equals new player rankings. So what we're saying here is we create in our property of player 1, which is of type player rankings, which is the class, and we say instantiate this player rankings. So what we're doing is when we create a new instance, we basically we're using a constructor to say construct this class for us. By default, I haven't defined a constructor in the class. So C# knows, okay, if I haven't defined one, I'll create behind the scenes a constructor by default. But in my case, I do actually want to create a constructor because I want to construct a class with a gamer tag. So I want to be able to say player 1 should be Jared. And then I want to be able to say console.writeLine output my gamer tag. So at the moment, if I just said this and then a console.writeLine and said player 1 dot gamer tag, so that's the property I can call on. This shouldn't output anything because we haven't defined it yet. It's not been created yet. We've created the class by instantiating it, but there's nothing to say here what the gamer tag is. Of course, I could say gamer tag, player 1 gamer tag equals Jared. I could do that here. But why would I do that? I can say this, but we know every time we create in a player ranking, we want a gamer tag associated with it. And this is where a constructor can come into play. So if I go back to player rankings, right at the top here, it doesn't matter where you put it as long as it's in the class, but I tend to put them at the top. You can say public player rankings, and a constructor has to be the same name as the class. And here we can say, okay, pass through a string of name or gamer tag, whatever we want. And here I want to say gamer tag equals name. So if we go back into our program file now, what you're going to see is we have this red error, which is saying there's no argument given because we'd expected a name. So now I can pass through, say, commit quality. And now, because in our constructor we said set gamer tag to whatever the name value we passed through was, we should now see in this console.writeLine, the player1.gamer tag has the value of commit quality. Perfect. So that's just starting it all off. We now created the constructor that we want. Now what we can do is we can start doing things from our class. We can start saying, maybe let's call on game time. So let's say player1.gametime. And we run this now, and going back to the method we had of game time, we're expecting in-game hours to add 1 onto it. So it starts off as 0 because we haven't set it to anything. It's added 1, so we'd expect to see commit quality has logged another hour. Game time is now 1. So if I hit run on here, here we are. Game time is now 1. And as you can expect, if I kept adding this line of code, it's going to keep increasing for us. So let me just execute this. And here we are, it's now increasing to 2 and increasing to 3. So we're using the methods from inside this. It's all being handled by this instance of the class we have created. So for example, if I created another class here and called it player2, and I named this one Jared, what I can say now is player1.gametime, and I could also say player2.gametime, and then maybe another player2.gametime, and now they're handled independently of two separate instances of the same class, where we're saying player 1 has logged 1 hour of game time, and player 2 has logged 2 hours of it. So you can see this is how you can start creating multiple instances of the class and keep everything separate. But we just said we want to, check if our score is better than the last score. So let's get rid of player 1 and player 2 because we've just shown an example of how you create different instances. But now what I can say is bool better than last. And we'll say equals player 1 dot better than last score. And let's say 200 is our current score. Based off this return value, we'll return an output. So we'll say string output. Let's use our ternary operator here. So I'll say better. If it's better, we'll say, yes, you done better. Else, we'll output try again. And now we can say console.writeLine output. So by default, we know that the first score is always going to be better. So that's always going to turn, yes, you done better, because it's the first score. But now let's do it again. And let's say, first of all, 201. So then it should be, say better than last 2, we'll say output 2 here, just because we've got to change the variable names. So here we should still see, yes, you've done better, because it's taken the score of 200, which was the last one, inside our method in here. Because here you've got int score, and it's checking last score, and it's always saving last score for us. And then let's do it one more time, but we'll make it worse. So we'll say better than last 3, but 3 here, and of course we want to output 3, and here let's just set a value of 22. Of course, this is all repeated as well, so this could be a method in its own right as well. So we're already seeing now, through the progression of our video series, we're seeing things that we can already improve and refactor and make it less repeatable. But for this example, let's just keep it as it is. And what I'm expecting is in the first one, of course, we've done better because you had 0. The second one, which I haven't actually used, which should be here, and this one should be 3. Lucky I spotted that. And the second one, 201, is higher than 200, so we should say, yes, you've done better. But then this last one, we done really bad. We only found 22 bugs instead of 201, and this one should output try again, because the Boolean value should be false. So let's run it and see if I have done this correctly. So here, we've got our last score was 0, so of course, yes, you've done better. Well, of course, we also added this in-game hour, so you can see we called on the method inside the better than last score method, so it's outputting this as well. So first, yes, you've done better. Now we scored 201, and our last score was 200. We've also increased our game hours to 3, and it said, yes, you've done better. And this last one, where we scored 22, our last score was 201. It's told us we've logged a game hour. But, of course, it's telling us to try again because we didn't beat our last score. Now, we touched on the kind of internal access as well. So what if I change this to private? Well, let's go back to our program file. Let's run commit quality. And what you see here is better than last score has gone red, and it says it's inaccessible due to its protection level. So I could use this method inside this class, but anywhere else, I wouldn't be allowed to use it because I set it as private. So that's a good example of showing you kind of the different use of these access modifiers. We touched on how we can create multiple objects of the same class when we created player 1, player 2, so you could see how you can add different people into the game as well. And the last thing I want to touch on was in the last video we talked about method overloading, but we didn't touch on it in the last video because I had an example of how we could use it here and it'd make a lot more sense and to make things a bit more fun. So inside player rankings, what I want to do is I want to have another method which is the same as better than last score, but maybe it's doing a little bit different to what I've done inside here. So what I want to say is just copy this for now. And we've got a method name of better than last score. And I'm going to say int score, and then I'm going to say int bonus. We have the option of calling this method or this method for better than last score, but this one is going to take in a bonus parameter. So here I'm going to say, I'm just going to change this to say it should be bonus plus score. We'll increase game time and keep that the same. And now I'll say int score plus bonus. If that's greater than the last score, return true, else return false. And of course, we want to make sure the bonus has been added to the score as well. So what we've done now then is we've created two methods with the same name, with different parameters being passed through. And this is known as method overloading. Before we added this, basically what was happening, C# goes out and looks for the method name, but it also looks out for the arguments passed through the method into the method as well. So this means we can do this thing called overloading, where we can have another method which might be named the same, but it's doing something a little bit different. In this case, it's taken through a bonus score. So what we've got here is this still works completely fine using better than the last score, but now let's add a fourth one here, where we say better than the last score, and we'll add a bonus of 10. And you can see C# has already picked this up and went, okay, I found better than the last score up here, which takes in just score, but I also have this overload method, which has bonus as well. So I can say here, output 4, better than the last 4, and output of 4. And now what we should see is we have exact same output. We have this extra method called here, which is going to say, yes, you've done better. And now our last score is going to be 22 and our top score is going to be 32 because we've added the bonus onto it. Here we go. We've got the last one here of scored 32. Your last score was 22. So we've just used method overloading inside our player rankings. And that's kind of all I really wanted to show. And what you're going to see is when you're doing different things, you can have multiple classes of things. So let's think of this kind of game now. We've just created a player rankings class. But then if we wanted to make, say, a game where you're moving around, like say you're using C# with Unity, you'd have a class which would be like your player ranking or your scoreboard or whatever you want. Then you'd also have other class for like player movement. You might have a class for player health. So if you're creating maybe a side-scrolling game where you need to use the buttons, you've got your class for player movement, which is everything handles the player movement because that's what you've named it, and that would make more sense. But then you might have a class which will have player health. So that will handle all of the methods that handle what happens when you add health or remove health from a player. And that builds up your whole program then, and then you can create instances of the classes like we've done here and build up your game. And that's really it. Through this series, we've gone through the basics of C# where you have enough knowledge now where you should be able to start putting together programs which use classes, methods, variables, looping, conditionals. I hope this has helped you. As always, if you do have any questions or comments, please drop them down below. A like and subscribe is appreciated. And as always, thank you for watching and have a great day.